Okay, let's look at how we would deal with a situation like this. Let's suppose that we've got y equals f of x times g of x. Now we know that when we have f of x plus g of x, we can find the derivative to be just the derivative of f plus the derivative of g. But what about a product? In fact, it's not the case that we can just generally take the derivative of the first times the derivative of the second. Generally, that's not going to work. So what we need is we need a product rule. A product rule. Something for dealing with a product like this. Now, let's see if we can figure something out. So if I want to find a way to differentiate a product, what I need to do is I need to go back to the difference quotient. And the difference quotient is, remember, we're going to take the limit as h goes to 0, and we're going to do this. We're going to have f, we're going to plug in the x plus h into the function. And in this case, the function is this product. So I put in the x plus h minus the function, which is f of x times g of x. This is the derivative right here, this one. And what we've got to do is figure out, well, can I simplify that at all? In other words, I don't want to have to try to go through here and simplify this every time. Is there a shortcut? Well, there is. So let's do it. Let's see if we can do that. Now, there's a little trick here. What I'm going to do is I'm going to take this function and I'm going to add I'm going to add something to it and then subtract it off. So in fact, I'm doing nothing. It's like I'm adding 0. It's just a little algebra trick. So I'm going to add f of x plus h times g of x. See, I added that, and then I'll subtract it off. So really, it's like I've done nothing. See? And then I subtract off the f of x, g of x, just like before. Okay? So, let's see what we've got now. So the deal was, I did this little trick. I added and subtracted this part. See this part right here. And when you add it and then you subtract it off, really, it's just like you've added 0. So, since really I did nothing there but add 0, you might ask, well, why did you even do that? Well, I did it so that I could rearrange things. And remember, I'm trying to come up with a formula. So here's what I want to do. I want to regroup things. So I think what I want to do is I want to take this first term and I want to put it with this term right here. See? I want to put these two terms together. And then I want to put these two terms together. Okay? So let me do that. Let me take this this first one right here. And I'm going to take f of x plus h, g of x, minus f of x, g of x. See? I just put this one and this one together. And then I'll put the rest of it together. So I've got this one, f of x plus h, g of x plus h, minus this part. Yeah, I just did a little bit of harmless regrouping there. Okay, and that was the whole purpose for me adding that 0. Okay, now, notice I could break this up. I'm going to take this part over here and give it its own limit, and this part over here and give it its own limit. They're all over the same denominator, so I can do this. I can immediately write this way. I can write this as the limit as h goes to 0 of this first part, f of x plus h, g of x, minus f of x, g of x, over h, plus, see, plus, give this second part its own limit. Okay, and I got f of x plus h, g of x plus h, see, minus f of x plus h, g of x, all over h. See? Just group things together a little bit differently. And now I have two limits. Now, if you look at this limit here, you notice I've got a g of x here and I've got a g of x here. Now, g of x doesn't have anything to do with h. So I'm just going to pull that out front. You know, I could put a limit in front. I guess I should do that. But it doesn't matter because the limit as h goes to 0 doesn't affect g. And then I've got this. I've got the limit as h goes to 0 of f of x plus h minus f of x over h. See? This first part has just been rewritten this way. Now, I want to do something similar over here. Over here, I'm going to factor out the f of x plus h, and I'll give it its own limit because it does have an h with it. Okay, and then in here I've got g of x plus h minus g of x over h. Okay. Now, look, for this first part, this is just, notice this right here, this is the derivative of f. That's what that is. That's f prime. So this whole first term here is f prime of x, g of x. See? Now let's look at this one over here. What is this? The limit as h goes to 0 of f of x plus h is just f of x. Okay, so this is just f of x. This is just the definition of the derivative of g. So this is g prime of x. Ah, look at this. I think we found a formula here. Look at this. The derivative of the first times the second plus the derivative of the second times the first. Okay, so let's see how this goes. If we want the derivative of a product, fg, we could write this as f prime g plus g prime f. Yeah. And this is the product rule. Okay? So notice, it's not the same as just f prime g prime. It's f prime g plus g prime f. Yeah. So let's see how this works. Let's suppose that we've got a function like 2x plus 3 times 5x plus 7, something like that. And we want to differentiate this. Now, of course, you could multiply this out and then use the power rule, term by term. But here's how it would look using the product rule. We have the derivative of the first. Well, that's going to be 2. See? Derivative of 2x plus 3, that's just 2, times 5x plus 7. This is f prime g. Plus, now let's do g prime. G prime, the derivative of the second one is 5 times f. See? So here's g prime f. Now what I'm going to do is simplify it a little bit. I'm going to multiply and then add like terms. So if I multiply this first term out, I get 10x plus 14. If I multiply the second one, I get 10x plus 15. And then if I add like terms, it looks like I'm going to get 20x plus 29. There we go. And there's your derivative. Now notice, this is using the product rule. In this case up here, we could have multiplied everything out. In other words, I could have just said, okay, if I multiply this out, I get 10x squared. See? 10x squared. And here's 14 plus 15, that's 29x plus 21. And then if I differentiate that using the power rule, I would go in 2 times 10 is 20. And then derivative of 29x is just 29. And there it goes. Notice I get the same thing. But this is how we use the product rule.